Guys, today we'll know the different kind of solids in the water, which is just the theoretical discussion. In our next videos we'll do the practical demonstration to find out the different kinds of solids in the water. The term solids basically refers to the matter which is either suspended or dissolved in water or wastewater or sewage. Another term, which is called dissolved solids, refers to the materials that are completely dissolved in water. These solids are filterable in nature. They can be filtered, and it is defined as a residue upon evaporation of filterable samples. The term suspended solids, another term, can be referred to materials which are not dissolved in water and they are non-filterable in nature. Okay. And it is defined as a residue upon evaporating of non-filterable sample on a filter paper. Here we have to make sure what kind of filter paper we are using. Usually for the finding of suspended solids we prefer cellulose acetate or a different kind of filter that's called membrane, sometimes Wattman filter or glass fiber filter. This is called the total suspended solids. Now there is another term which is called the volatile solids. The volatile solids here refers to the organic portion in the water samples. Usually for finding out the volatile solids, what we take sample and then we ignite the residue, and this ignition represents the burning, represents the loss of weight due to ignition, represents the volatile solids. And also there is another term which is called fixed solids. Usually the volatile solids is, as I told you earlier, is the organic portion, and the fixed solids is the will represent the ash after ignition, and that basically refers to the inorganic portion. Now let's go how basically we will carry out the experimentation here. Now usually for the samples that we going to collect should have some solids, and also we have to make sure that the samples should be well homogenized, and we have to refrigerate the sample at 4 degrees C up to the time of analysis. If you are going to do the analysis today, so it should be stored a day before to minimize the microbial, or you can say microbiological decomposition solids. You should not hold the sample more than 24 hours. In case you hold this in more than 7 days, you have to make sure that you bring the samples to the room temperature. These are general precautions for doing any kind of analysis, even if you are doing the pH or turbidity or whatever kind of analysis in the water samples. Now we need a certain kind of device. We need the dish, porcelain dish, which is 90 mm diameter. We need if suppose we are doing for the 100 ml of the samples, we need platinum crucible or high silica glass. We need pipettes, we need glass filter disc, suction flask, aluminum dish, and also we need muffle furnace, or you can say the furnace which can operate up to 500 or 600 degrees C. The steam bath, desiccators for cooling down the samples. We need the drying ovens. Let's suppose we are going to 100 or 200, and also we need the analytical balance, which can have minimum, it can be 0.1 milligram, and also it can go till 2, 3, 5 grams. And steam, and we need the filtration apparatus. Let's suppose we are doing the total suspended solids in the water. Usually for carrying out the total suspended solids in the water, we either can go use the gravimetric analysis, which is just based on the mass, or either we can use the vacuum filtration technique. Magnetic stirrer for homogenizing the samples. We can also homogenize the sample using a glass rod, crucible with adapter, Imhoff cone to find out the settleable solids. I forgot to tell you about the settleable solids. This is another kind of solids which is called the solids which is find out by the settling. It refers to the settleable solids in the water sample which settles in Imhoff cone. You can either use Imhoff cone, or you can use the any graduated cylinder that should have around 1 liter. It should hold around 1 liter of the water sample. Usually the waiting time is 30 to 45 minutes. So after settling, it will give you the settleable solids. Now usually the units that is used to find out, which is used to show for total solids or suspended or dissolved, is milligrams per liter. But in case of settleable solids, the unit is milliliters per liter. So these are different devices. You can, so this is a desiccator. Usually in desiccator at the bottom we put the silica gel that is used to absorb the moisture. This is a furnace. Usually in our labs we have the furnaces which can hold till 3000 degrees C, and this is a balance. So balance are of various brands. They have various accuracies. It can go till minimum how much it can weigh and maximum how much it can weigh. This is the depiction of the method. The Imhoff cone here you can see is used for the finding out the settleable solids, and this is the stirrer with a magnetic plate. This is magnetic stirrer. Usually this is a, you can say, or a hot plate also. This is the dish which is used to find out volatile solids, and these both are evaporating dishes which can sustain higher temperatures. Even if you burn at 500 600, this can sustain that temperature. Now the procedure. Let's come to the procedure. Before coming to the procedure, we should know which method number is basically used to find out the different kinds of solids. Usually for finding out the solids in the water, the method USEPA method is 600, Bleak 4,79020, or USEPA method, that is 160.1. Let's memorize USEPA method 160.1. So if somebody is putting the reference for the method, so the USEPA method is 160.1. Now the procedure for finding out the total solids. Total solids is the amount of solids which is suspended or dissolved. So it's the sum of them. What we have to do, we have to take the sample, take the beaker and dry it out so that there is no moisture, and then we would take the beaker in the desiccator, cool it down, then take the weight, and then we will take the homogenize around 100 ml sample or 25 ml sample, whatever amount you are taking. We will put the sample in the beaker and dry it for a few hours, around 1 to 1 hour, till the water is evaporated. So this will give you the total solids weight difference before and after. Then for the finding out the total dissolved solids, what you have to do, you have to take a filter paper and filter it out. Whatever the solids are on the filter, that is the total suspended solids, and which is passing through the filter is called the total dissolved solids. You would take the beaker initial weight and the final weight. This will give you the total dissolved solids, and in case of suspended, whatever portion is remain on the filter is your total suspended. So in that case also you have to take the initial and final weight of the filter. This would give you the total solids. Now the volatile solids. So volatile solids can also be found out on the whole sample, and also on the whatever portion of the solids is remained on the filter, or whatever solids you have filtered. That has passed through the filter also. Let's talk about the volatile solids as a whole. So the volatile solids as a whole, you can take the whole sample, whatever sample you have taken in the beginning. In case of total solids, the same beaker you would put, and also you have to make sure the crucible that you are using has to be robust enough so that it can withstand higher temperature. You have to keep the same beaker in the furnace for around 1 to half an hour, and then you would take the difference in the weight. This would give you the volatile solids. This loss of weight due to ignition is the volatile solids, and in case of fixed solids would be the inorganic portions. You will take the initial weight, that is the beginning, and then the final weight difference. So this would give you the fixed solids. Now these are the theoretical discussions I told you earlier. If we do if we show you the demonstration live in the lab, that will make the things more clear. These are the formula. So let's see the formula for the total solids. So total solids, you can see, is the difference A, where A, I told you earlier, A is the weight of dried residue plus dish, and this is the weight of dish. So this is A minus B. So you can say this the final weight A, and this is the initial weight, or you can say the tail weight also. Now the same formula will be applied here also. The difference is only in case of total solids is the whole. You are not filtering, you are not taking the non-filtered or filtrate, whatever I told you earlier. Now and the unit also in case of all solids except settleable solids is ppm or milligrams per liter. And in total solids, total dissolved solids, you have to dry at 180, and in case of total solids you are drying at 103 to 105 degrees C, and in case of fixed and volatile you are going to dry at 550 degrees C. So there are calculation involved in all cases for the computation of all kind of solids except the settleable solids, where you don't need any kind of calculations. That's only the record, and you have to record the time and the volume, that is milliliters per liter. And you have to make sure the how much time you have to start the stopwatch. It's around 30 to 45. Depend on the quantity of the sludge that is present, or the solids that is present in your water sample. This was the whole discussion about the different kinds of solids in water. And also there is one more thing. If there is a correlationship between TDS and the conductivity of the water. So if you know the conductivity of the water, I hope you have seen my earlier videos where I talked about, if you know the conductivity of water, you can easily compute the value of the total dissolved solids. That is, total dissolved solids is equal to K into EC. So K is a constant which is fixed. This K is basically based on the experimental evidences, researches. So if you know the TDS, you can find, if you know the conductivity, you can easily find out the total dissolved solids.